In section 5.1, we learned how to use the standard normal distribution to look up areas, and that translates into finding probabilities. In section 5.2, we are going to apply that to some story problems to be able to figure out probabilities. So here's the thing. If you have a normally distributed random variable x, you can find probabilities that x will lie in an interval by finding the area under the standard normal curve for that interval. So the way that we do this is first we will find the z-score or z-scores. Remember that the z-score is equal to the data value minus the mean divided by standard deviation. So we have, just in words, data value minus the mean divided by standard deviation. After we know the z-score, the second thing we are going to do is sketch and shade the standard normal curve. Then we will look up areas in table 4 and interpret the area that we look up in the context of the problem. So let's just go ahead and start. A survey indicates that people keep their cell phone an average of 1.5 years before buying a new one. The standard deviation is 0.25 years. A cell phone user is selected at random. Find the probability that the user will keep his or her current phone for less than 1 year before buying a new one. Assume the lengths of time people keep their phone are normally distributed and are represented by the variable x. So we want to know the probability that the user will keep their phone less than 1 year. So the probability that x is less than 1. The first thing we're going to need to do is we are going to need to change this to a z-score. So I have to change the value of 1 into a z-score. So the z-score would be the data value, which is 1, minus the mean. Here's my mean, 1.5, divided by the standard deviation, which is 0.25. So I need to put that in my calculator and I can't find it. So I'm going to do 1 minus 0.5, which is negative 0.5, divided by 0.25, gives me a z-score of negative 2. So finding the probability that x is less than 1 is going to be the same thing as finding the probability that I have a z-score that is less than negative 2. So what I want to do is sketch myself a little standard normal distribution, label 0 on there. I know negative 2 is somewhere down here. Don't need to be too accurate, but I'm looking for the probability that my z-score is less than negative 2. So that's going to be this area. Remember, we're going to use table 4. So I need the negative z-score of negative 2.00. So I've got to go all the way over here to the 0, 0 column. So negative 2.00. The area to the left of that z-score is 0.0228. So this area is 0.0228. And since that area is the shaded region that I'm looking for, then I know that the probability that z is less than negative 2 is 0.0228. So in the context of my problem, that tells me that the probability that a randomly selected person keeps their phone less than a year is 2.28%. Now, since that probability is less than 5, I can also say that this is unusual, because a probability of less than 5% is considered an unusual event. Okay, let's do another example. The average speed of vehicles traveling on a stretch of highway is 67 miles per hour. There's my mean, with a standard deviation of 3.5 miles per hour. A vehicle is selected at random. What is the probability that they are violating the speed limit of 70? So the probability that their speed is greater than 70 miles per hour. Assume that speeds are normally distributed and represented by the variable x. So I want to know the probability that my speed is greater than 70, but I need to convert that speed into a z-score. So my z-score will be the data value of 70 minus the mean of 67 divided by the standard deviation of 3.5. So when I work that out, I'm going to have to go locate my calculator. Hang on one second. Got it. I'm going to take 70 minus 67 and divide by 3.5. Now this gives me a whole long string of numbers, but if you remember on your standard normal distribution that z-scores only go out 2 decimal places, I'm going to be working with 0.86 for my z-score that I'm going to look up on the table. So when I sketch my little normal curve, I'm looking for the probability that z is greater than 0.86 because it was a greater than up there. I just converted it to z's instead of x's. So here's 0. I know 0.86 is to the right of 0, and I'm looking for the probability that it is greater than. So when I look up my z-score of 0.86, that is an area of 0.8051, but that area is to the left of my z-score. So when I look up that number, this is 0.8051. So my shaded area is going to be 1 minus 0.8051. So the probability that z is greater than 0.86 will be 1 minus 0.8051, which is 0.1949. So the probability that the randomly selected person is speeding, going over 70 miles per hour, is 19.49%. Now, I could kind of convert that into actual numbers. Let's say if there were, I don't know, 500 cars. How many of the 500 cars would you expect to be going over 70? So what I would expect is 19.49% of my 500. And in working with percents, that means we're going to be multiplying. So I have to make this into its decimal form. 0.1949 of 500 would mean I'm multiplying. That would give me about 97 cars. Okay, a couple more examples. A survey indicates that for each trip to the supermarket, a shopper spends an average of 45 minutes with a standard deviation of 12 minutes in the store. The lengths of time spent in the store are normally distributed and are represented by the variable x. A shopper enters the store. A. Find the probability that the shopper will be in the store for each interval of time listed below. We're just going to go with more than 30 minutes. I don't know where that went. So we're going to say more than 30 minutes. So the probability that the shopper is in there for more than 30 minutes. And then B, I want to know out of 200 shoppers, how many would stay longer than 30 minutes? Okay, so my first job is to convert my X score into a Z score. So if X is 30, then Z would be 30 minus the mean, which was 45, divided by the standard deviation, which was 12. So 30 minus 45 divided by 12 is negative 1.25. So I want the probability that my Z-score is greater than negative 1.25. So here's my little sketch. There's 0. Negative 1.25 is on the left. And I want to be greater than negative 1.25. So we're over here. If I look up negative 1.25, negative 1.2, and then down from 0.5, that is 0.1056. But remember that that 0.1056 is over here, 0.1056, which means that my shaded area is 1 minus 0.1056. So the probability that my Z-score is greater than negative 1.25 would be 1 minus 0.1056, which is 0.8944. So the probability that a shopper would spend more than 30 minutes in the store is 89.44%. Then I want to know out of 200 shoppers, how many would be expected to stay longer than 30 minutes. Well, it would be 89.44% of my 200 shoppers. So 0.8944 times 200 which would be 178.88. So I'll go with 179 stay longer than 30 minutes. On the other problem here, I want to know what is the probability that the shopper will be in the supermarket between 33 and 60 minutes. So here I have the probability that they will be in there between 33 and 60 minutes. So I am going to need to have 2 Z-scores this time. I'm going to need to make 33 into a Z-score. So I'll do the data value minus the mean, which was 45, divided by the standard deviation. So I got 33 minus 45 divided by 12 is negative 1. So the probability that the Z-score is bigger than negative 1, but smaller than 60 minus 45 over 12, 1.25. So on my little picture here, there's 0. I want to be bigger than negative 1, but smaller than 1.25. So we are in here. Remember that when I have an area between 2 Z-scores, I'm going to look up their areas and I'm going to subtract them. So I'm going to find the area for 1.25 and then I'm going to subtract the area for negative 1. So I take my bigger Z-score, 1.25, look that up. That is 0.8944. I'm going to take 0.8944 and I'm going to subtract what I look up for negative 1. So negative 1.00 is all the way on the end. So that is 0.1587. And if you forget which order to subtract, you will end up with a negative number if you do it backwards. And since probabilities always have to be a number between 0 and 1, if you get a negative value, you should be thinking that's probably not right. So when I subtract those, I get 73.57% probability that a shopper would stay in the store between 33 and 60 minutes. So if I do part B, out of 200 shoppers, how many out of 200 would I expect to stay in the store for 33 to 60 minutes? That would be 147.